We know not every equation is going to be a one-step nonlinear, like the simple equations we solved in the previous lesson, in lesson 4.1. So let's practice how to solve for x when the nonlinear equation requires more than one step. As usual, the goal is to isolate the x. We want that x to be completely by itself. And in order for the x to be completely by itself, we need to take care of the negative 27 and the 2 in the exponent. And this is very similar to the two-step linear equations we solved in Unit 3. We start with the subtraction, so negative 27. The opposite of a negative 27 is a positive 27, so they can cancel. But if we added 27 on the left, we must add 27 on the right. Now we do the operation. 94 plus 27 equals 121. And now this is a one-step nonlinear equation in which we can take care of the exponent of 2. And we know the opposite of an exponent, as we learned in lesson 4.1, is a radical. But the radical must have the same index as the exponent. So if this is an x squared, then we must take the square root. That way the radical and the exponent cancels. But the golden rule of algebra remains. We do it on one side, we must also take the square root on the right side. The square root of 121 is equal to 11. Always pay attention to the index of the radical. This is an even number, and for even numbers, we must consider both the positive and the negative solution. So the two possible solutions to this problem are x equals 11 and x equals negative 11. And the reason why I always say possible solutions is because, remember, especially when working with word problems or when working problems in physics that require math or areas like chemistry, economy, when you get both positive and negative solution, you must analyze, given the previous information, which one is the true solution, the positive or the negative, sometimes both, sometimes none. Let's do one more example. This one seems a bit harder because the x is inside of the parenthesis. The 2x minus 9, including the x, is inside of the parenthesis. And on the outside, we have an exponent, which means we first have to take care of that exponent. We first have to move that exponent to the other side in order to delete the parenthesis, and solve for the x inside of the parenthesis. And the way we have been practicing, the opposite or the inverse operation of an exponent is a radical. So if we have an exponent of 2, we make a radical 2. That way, the radical and the exponent cancels. But if we do a radical 2 or a square root in this case, on the left side, we must also do it on the right side. And we have to take care of the square root of 169. And this is an even index. The index of that radical is a 2. Because it's an even index, remember, we must consider the negative solution with the negative 13, because radical of 169, square root of 169 is 13. So we must consider the negative solution with the negative 13 and the positive solution with the positive 13. And now we have to solve two equations. Let's solve first the left side, the negative solution. This is a two-step equation as we solved in Unit 3. We first take care of the negative 9, then we take care of the 2 multiplying the negative 9. So the inverse operation of a negative 9 is a positive 9. We cancel the 9's, but we must also add 9 on the right side. Negative 13 plus 9, so 13, we can do it as 13 minus 9, which is 4, but because the 13 is bigger and is negative, the answer is negative 4. Then we take care of the 2 multiplying by dividing by 2. That way we can cancel, but we must also divide the right side by 2. And then we do negative 4 divided by 2. There is only one negative, so our answer is negative 2. Now we take a look at the right side, the positive solution, and the steps are the same. Minus 9, that means we have to do plus 9 on the left side of the equation. The 9's cancel, and then we do plus 9 on the right side as well. 13 plus 9, 22. Then we divide both sides by 2, so the 2's on the left cancel, and 22 divided by 2 is 11. So our two solutions, or our two possible solutions of this multi-step linear equation problem are x equals -2 and x equals 11.